Hello and welcome back to the Google.rs development stream. It's Byron speaking. And in the previous session, we have basically laid out the infrastructure to be able to use our cursor to set any kind of value in this JSON value structure, which is very flexible. And it is actually compiled. We had to adjust a few things because the deserialization trait needs to be implemented for all the types that we want to obviously deserialize at some point. That's where this is happening. That's basically the new code that takes our object when it's done and then deserializes it into the actual structure. And previously, not all the structures had the deserialization trait. Now this is the case. So basically now all the structures that come from the API can be serialized and deserialized fully. And that is that. Also in the previous session, we have greatly simplified the entire code here. I mean, that's laughable what's remaining here. And actually, that's a good thing. I like laughable because laughable is easier to understand. And, and obviously less code in all areas. So we saved 25% code by doing that. Quite amazing. Right. And of course, we set ourselves up to be more flexible in future, which is what I actually want, Personally, I probably wouldn't care. But of course, we also save in build times. And I switched to a different one now. I'm now operating on admin email migration because that's the smallest one that has all the features we need to see how this works. Even though for actual testing, YouTube will be required, but as building takes so long and, it even rebuilds stuff that it shouldn't rebuild. Yeah. I mean, look at this. Actually, nothing changed here. I just built it, and it's still rebuilding everything, And this is a major issue here. And I would love to get rid of that somehow. I would even roll back to an older cargo. Maybe just build it myself. Unfortunately, cargo doesn't use cargo, so you have to go through a different build process. I never tried it. Probably it just works, but it's not like simple, straightforward. Oh, I want to use an older version of cargo. Let's build it. But I will consider it because that is a major issue for me here. I mean, even the small ones take a long time and you don't want that. It's so annoying. Why is this always creeping back in, man? Hate. Honestly, this is like if your major tool gets destroyed, then people start to get red eyes and be full of hatred. So it happens to me. I don't try to be positive, but when it spikes you every time you wanna compile, look at that, still doing it, even though it would have been done already if it wouldn't rebuild everything. Oh man, I think and the build process gets slower and slower every time. That's how it feels, because that's just a few hundred lines of code here. I mean, that's I think one of the major flaws, and I totally hope that with Rust 1 things will measurably and improve. So look at that. I didn't change a thing. And there we go. Oh, it wants to rebuild the API. I think what happens is that it kind of figures that the API has changed, even though it didn't. And that's the problem. This probably is something. I mean, I don't really want to debug this, but it has probably to do. Let's try one thing. Groups migrate, admin, email, cargo. So that's the API. And this one here, points to the one it should use with a path. And what would happen if I use an absolute path? Maybe it's the relative one that it doesn't like. Maybe it can't detect it anymore, This could be something, and then it has to rebuild everything. And this would totally be worth a new issue. Maybe they fix it before release, because that creeped in recently. So where is that? I think it's in Gen, admin to email migration. We want to go to the API. So that is actually that. So this is the path you want to put in, and let's see if the absolute path works better. Boom. So now it might want to build it once. That could be all right. but it shouldn't build it twice. And apparently the absolute path worked so far. I mean, it didn't rebuild anything, and it picks it up. That's great. But yeah, I think I'll set up an issue for that. So let's see what happens if I rebuild this, if it makes any difference. And let's see if people can reproduce this by just checking out my repository. I will try that, because in theory this should work, because I checked in the code. You should be able to just run it. Yeah, so let's do it. I will get a fresh one just to get something that can easily be reproduced. Here we go. Yeah. I think I will go to temp. Oops. Get a fresh checkout. Can I go like this? Oops. Maybe like this. Branch. Actually, I think I want master. Yeah, so master I get anyway. But I want nothing more. Let's see if that works. Just master, please. Okay, so that compiled. Let's see if it compiles again, because then at least it does compile again. So this makes no difference at all. Fine. Why does undo not work? It would work if you would press the right buttons. That's usually the thing. Okay, so it just rebuilds it no matter what I do. And yeah, I'm going to reproduce this now, and I'm going to make a new ticket here. Yeah, so that's this one. That is 12:15. Let's refer to it. Actually, we refer from the other one. So if I can reproduce it. Rebuild projects unnecessarily. Cargo always rebuilds crates if path is used in dependency configuration. I just put it to that because that's kind of the main discriminator that I have here. So here I am with that. So I should be able to just go in here, like groups migration 1 CLI, and hit cargo build. This should already do it. Yeah, and this way I should be able to reproduce it. Of course, I have local overrides of stuff, which people will need as well, but for the purpose of demonstration here, I should be able to reproduce it. That's the point. Groups migration is a very small one. Yeah, while this is working in the meanwhile, it's so annoying, man. This destroys my workflow. And I thought I had one. You know, I was quite happy with the compile times of small programs that help me to test. So I will compile less. That's just it. I will compile at the end of a session or something. So now it's all about setting the value. This is really what we have to implement here. And to do this, let's see how we store our fields. Fields are a vector of strings. That's the fields in order. So yeah, we can actually just iterate our fields here and try to unpack the value as we go. And I wonder, yeah, so if we're at the last field, then we try to unpack an actual value, and if not, we will not do that. So first, I think we want to set up we want to get a mutable borrow to something inside of the value structure. And now I'm hoping that the borrow checker will be nice enough to allow us to do that. Maybe we can just forget about the primary borrow and override our object to point to a sub borrow. So let's try that. For field in self null. So here we go to our last one, self null lang. This is an exclusive range, so -1 will give us possibly an empty one, and we should actually prepare. And I don't know, should it be an assertion? Yeah, let's assert for it. Of course, this assertion is kind of implied by this check here, but let's just say I'm aware of this, and I don't care about this double checking. It doesn't matter. So assert self 0 lang is greater than 0. That's something I need. So then this is, in the worst case, an empty slice. And it will be a slice once we start getting a borrow of that return slice. Like this. So now we dig down and just say, okay, value is, and we have to unpack it. Match value. So I'm always a bit confused here when you match. I think there you don't steal anything. There you don't try to take ownership. So I just deref it to be able to match on this thing. And if it's an object, JSON value object, then we are good. Then we can unpack it. That's as far as my knowledge goes. Then we get a ref mat of a map. Ref mat mapping. And we return the mapping. So we kind of try to unfold it and override our actual value here with it. And we keep using it so that we can dig down into the structure. The problem that I see here, though, is that we will not be able to modify that value, which is what we would have to do. I mean, I also don't want to clone it or anything. So, okay, let's say in this case we are good. That's what we want. But we also have to set it up. So if it's something else, well, I don't know what it would be then. Oh, wait. That's not it. We have the mapping here, but we still need to put the field value in. So we want it to be a mapping, but it could also be no mapping. And could be anything else. Is this something we expect? Actually, it's something we do not expect. We want, but what if it's a single value? We don't support that, do we? No, it needs to be an object. It needs to be an object on the first level. And then we expect, and then we set the value later. So here, you basically drill down and say, well, if this entry doesn't exist, we set it up with a new value, which is also an object. This is what we expect. This is how we drill down. Okay, that's how that goes. And this will be a panic here. We don't expect non-object values here. Let's be very explicit about that. I like this explicitness. Cool. So now we have a mapping of a B-tree map, and I think there I want to use this entry method. Wait. Let me check something. Does it work? Yay, it's fixed. So entry, which allows me to insert something easily. Entry X or insert, that's kind of the thing what I want. So we go with entry for our field. It's a string here, the key that we have. And it wants to own it, so we just say to owned. Field to owned. I like this. Previously I used toString. Now I'm explicit and say I want to own this thing, which copies the string, obviously. So that's my key. Or insert, huh? Or insert at this key a new mapping that contains the key. So I think we can just set it up in a little substructure. And or insert, what does it return, by the way? Because I need that thing that I create here. And it returns the mutable value. That's great. So we can just leave it like that. So either we get... So in any case, we get the mutable value. It could be the new one or not. And this is what we want. So this is having the right return value, because it's which is gonna overwrite our one. And I guess I might have to say it's gonna be a mud reference, because it wants to strip these all the time. But hey, let's wait for it. Let's not get ahead of ourselves, because I'm not sure about this. Yeah. I think, in the meanwhile, I can also start uploading stuff. Because that export by now should be finished. It is. Thank you. Oh. And then I drop this here and I'm done. Good. So now back to business here. So here I want a new B tree map. I think I also have to pull this in. Is it a B tree map? B tree map. I think I'm going with the default one. Let type inference do its thing. B tree map new. Let map be this. Then we say map insert. I think it takes key value pairs. So we do. Oh wait, no, actually it's just supposed to be an empty one. Yeah, because we drill down that way. Yeah, forget it. So no special stuff required here. I'm dumb. All I say is B-tree map new. And because the less I know, the better. I say default. Whatever you need, have it. And that's type inference at its best. And we are done. So that will return a mutable borrow. And I think that's all we need here. So we drill down, have a value, which is an object. And then we can match on it again and do the panic stuff again. Or I could try to have this loop set up so that we say, well, if it's the last one, we do something else. So here we drill down on the value. Which we override. Well, the thing is, I will need to... Oh no, wait. That's wrong. We have to pack it up. No, wait, we don't. But what's the default here? And B-tree map of a string value relation. Yeah, so that's... This is what we have here. But the value itself, I think this guy doesn't implement default. I think that's where this default will fail. So yeah, let's have a new object there. JSON value object. And there we go, default. This will work now. Oh wait. So we are an object here. We get a mapping, and in there we want to put a value. That's what you want, and it should be an object as well. So this is what we do here, right? So yes, that's how that works. And that returns a value type mutable reference, which we can then use again. Yeah. Or insert this thing. JSON value object with, yeah, that's better. That is just empty. So this will be the B tree map here that we've seen before, but it will be empty. And yeah, we can handle that. Good. I mean, long story short, now we have a value. We have to match on it again. We assume it is an object. I could use if let and not care about the consequences. I could just be safe here and say, well, match on the value, please. And here's where we insert the actual specific type here. And I wonder, parse KW, we have a function for this that does the right thing. Which does the conversion. Arc from string. But in this case we already know what we want. That's the problem. So we just call parse from, but we know the return type. And here we do not know the return type. I could just do the mapping myself basically. But I wonder if there's a better way. I guess not, because the mapping from the type that we have to the respective Rust type, this is something we know, I think, but we don't have the mapping. And we also need to know if it's an array, I think. So array has to be handled specifically. So that's actually the fun part here. So we need an object, and then we need to match on the value type and do the right thing. And we have to figure out if it is an array of stuff or not. And I wonder where that is encoded right now. So if I go like, okay, tags, for instance, we handle specifically. Can I even handle arrays? Could I handle arrays before? I think I could, but I've removed all that code, obviously. What's the time saying? 23 minutes in. I might chop this off because I also feel like having lunch soon. But anyway. Yeah, I think there's no way around. We have to match on this value. And then we go with JSON value object. Get our mutable mapping. And in here we will have to, I mean, really this should be unreachable from here. And here we have to match on the actual value type. And I really want to see what kind of value types we are expected to get here, or what we expect to know. Oh, the is repeated information is actually it's actually something we might have lost here. But you might want to have this anyway repeated. See? Borrow prefix. So it's part of the property information that we should have here somewhere. but I don't know. Show. Oops. Really? I think from the log we can actually reach this more easily. Yeah. So is there repeated somewhere? Repeated? Nope. Ah, here, the FE container type. This is where it happens. Huh. So if it's a pod, we set it. If it's an array, we push. And if it's a mapping, I don't know what we do then. So we had support for all of this already, and now I killed support. Yeah, so I guess I want to have information. I want to use this information, which is at generation time, and put it into the basically informational structure that we built. Currently just contains the type, but we also want to know what kind of thing it is. Is it an array? Or is this supposed to be, is the value something we have to parse again? That's the thing here. This value unwrap thing, we might have to run one more time. And this is, something we have to do. This means in the worst case, our value within the mapping could be a mapping once again that we have to handle. Same with the vector, we might have to initialize the vector. But the good news is that all this handling code goes here once. Okay, so we expect to have a mapping, and this should always be fine. And here we then have to check our type, basically. Value type. And I think I want to have this not as a string, but I want to convert this in the using the generator, because there everything is easier, into the respective enumeration. Yeah, let's have another enumeration. This shall be part of our JSON type def or structure type. And this contains structure type can be then pod or array. And so we have kind of two enumerations here that I would like to combine. Oops. So let's set it up. Pub enum. Structure type. I don't know how to name it. That's the problem, because it's kind of both types. Well, structure complex. Complex. I don't know. I might rename it just at any time. So that's a pod. Then we have array, and then we have mapping or dict or something, and that's always, that's the thing. Then we have pub enum. What kind of type do we have here? Boolean, string. That is a JSON type. And we just go with these that we have here. So Boolean. And I just capitalize the names that you see here, as easy as that. Integer. And let's map it, let's bring it down to what we have here. Of course, string we have as well. Null is something we don't want, but I will just put it here for reference anyway. So Boolean we have, integer, for the purpose of setting the JSON values, we only have 64-bit support here. So integer, and do we have unsigned somewhere? integer and unsigned integers. That's kind of what we have. Integer 64. Let's call it int 64. uint 64. And then we have a floating point number. So this is something we have to convert, obviously, in the generator code. There we have to need a mapping from the one to the other. Then float double, this is all gonna be f64. Call it float. Actually, it's called int and uint because from the JSON perspective, we don't care. We just map it. The mapping part is, the mapping thing is determined elsewhere. Yeah, and previously we've been setting the structures manually, which means that thanks to the structures we had type inference and the parsing stuff would do just the right thing for us. But that was, of course, a lot of code bloat. So now we have more runtime decision and less code bloat after all. And string is string. So that's a direct mapping here. And these we have to specifically handle just to bring it down. Oh yeah, and every one of these JSON types can be having a complex type, which is either pod, array, or mapping. So this goes ahead with that, or because I don't like this bundling, we could have a struct JSON type info that contains both ways. So we have a JType, which is a JSON type. I hate the names, but what can I do? And complex type is complex type, and that's the JSON type info. And this is something we are now going to pass here. I would just own it, but just because this is what we have here, even though technically I would be fine with a borrow, but why not own it if we have the value because we don't need the value anymore, right? So this will be the end of the session once this additional infrastructure has been set up. So value type is an owned JSON type info. Let's call it type info. Okay. And I will also try to respect the lines a bit more. Like this, maybe? Yeah. Looks okay enough. All right. And what else is there? Now we have the type info. Let's generate it. If I look here, then here I wanna get type info out of there. Type info that I pass on here. Type info. So far so good. Now I just have to set it up here. So this is now a bit more complex. It's still an optional. Oh yeah, and we can unwrap that as well. That's weird. How did it work that we never unwrapped this thing previously? Oh, and I should have left open that show, but yeah. I guess I will think about that later because that's always and has always been an optional, and I didn't see it being unwrapped there. And this was always for unwrapping, I thought. It was always a direct type, so it was a string. Well, anyway, now we do the right thing, I hope. It's a sum, JSON info, JSON type info. Yeah. Log current file. So here's the pod stuff, is FE container type. This is what we have to map as well. So the P type is something we don't really want. We want the mapping here. And this is gonna, yeah, let's get the stuff in here. So we need both, all of that actually. We need complex type, JSON type info. Like that. Okay, now that we have this, we can set it up. I think the p type we should have. Fine, then we say j type is, and we could just have a mapping. Yeah, let's have a map. Why not? It's a bit of a duplication thing there. Type to enum, enum map. So that's simple. Boolean. Let's bring it up just to be sure. That's Boolean. Integer is int. Number is float. uint is int. Double is once again float. And float is also float. And int32 is int. Any is actually a JSON object which we can't handle. So for now we save it as string, that's okay. And int64 is also an int. Then we have this one uint instance. And these things, they shouldn't matter to us. And let's see if that is the case or not. So I hope I only get these simple type names here. And if I judge from what I see here, I think I do get them. Good. So type to enum map. Oops. Let's bring it in here. Type to enum map. And now we can just use a brute force mapping, which is expected to work like that. P type. And of course, not to forget, it's now a JSON type. So that's the full type name that I would expect to get here. And then we have a mapping from a complex type, like this pod stuff. Where is it? Here, C-type pod. Let's see how these are named, so that I can have a mapping. Where's the structural types? Pod list map. Okay, so we have a mapping here. Oh, it's actually in the wrong file. Sorry for that. I will attempt to roll that. Oh no, I changed it. I can check it out, but for make it will mean it rebuilds everything. But fine. There we go. I still used, oh, that's why the map was a bit different actually. JSON type to enum map it is now. Like this. Boolean integer. So yeah, that's basically the same thing, but a different mapping. And I guess I also want to rename this here. It's now a JSON type to enum map. And the last thing is a C type to enum map. C type to enum map, which shall be C type pod is pod. Yeah, that's how they are called, right? Pod array mapping. Yeah. C type array is array. And C type map is map. I just decided to rename this so that it's at least consistent among all the invocations. So this is a map now. And there we are. Good. I actually could call this vec here. Oh no. I don't know. I think it's just a syntax highlighting issue. It's not an issue with the name per se. We can call it vec. Yeah, totally. Let's call it vec. Then we have simple 3 name letters here. 3 letter names. That's very much appreciated. And that is that. C time to enum map. Let's bring it in. There we go. And now it's C type shall be complex type Cullen plus C type to enum map FE container type. Yeah, so this is how we get the information back that we have in the generator level and kind of put it as efficiently as possible into the respective structure, which is now a JSON field info structure that has a J type and C type. J type is now the J type and C type is now the C type. That seems quite straightforward. Yep, and it's a sum, not to forget. So that should actually generate at first. Then let's see what that does. That's this guy. Oh, I'm building as well. Why not? Why not go for everything? Okay, that didn't work. Key error. String is not in some list that we have. Is there some obvious error? Did we forget string here? It looks like it. String shall be string. There we go. Good, so it compiles, well, that's not good. That's the not so good part. It compiles the API again, and here we have a little issue, unexpected token null. Oh, do you want to tell me I can't access my own elements anymore like that? Because we are just a new type, a field cursor, and so far, how did I do it? Didn't I use .null? I did. Many times. And that worked before. Okay, so it's 235 minus 2. And it hates which one exactly? Okay, so that dot null. Oh, there is a dot here that I don't want. Yeah. So let's see if that generally works. Oh man, this API recompilation, it's annoying the hell out of me. Oh, damn it. So, unresolved name field type, which is, where is it? Main 86. Ah, yeah. So just here, field type. Ah, this is how I unpacked it. True. And this is a valid thing. So this is why that works. I'm blind. I'm so blind. So that's the JSON type. Okay. And we just set it to the same name. Oh, actually it's type info. Let's stick to the name. I like that I can just locally rename this without being bothered. So now, once it has compiled the API for the 10th time for no reason, we might get to the point where this gives us some other errors. But generally it works. I think that's the main point here that I want to make. 44 minutes in. So I'm totally willing to abort this. Let's turn off word wrap here. That's how that looks like. Looks good. It's all the information we need to set this thing correctly. And yeah, so what's up here? Expected string found JSON value. Really? What am I matching on? 237. Which is 234 something? Yeah. Oh, I should match on the object, obviously. Objects. Yeah, that's how that should look like. And maybe it even works. Who knows? But I'm seeing, well, field J type of struct common. Okay, true. So I can't export it. But now I can. There we go. Okay, that's totally unrelated errors, so I'm still waiting for the borrow check. Yeah, for the borrow check issues. Here they are. Here they are. Awesome. Reassignment of immutable variable objects. Already. Yeah, so here it goes, here it happens. So I might have to redesign that, and reassignment of immutable variable, but it's not technically immutable, is it? Do I have to call it mut? Oops. The daily apple m. I don't know. Okay, so that's something we shall tackle at a different time. Because at least now we have all the information there that we need. And that was kind of the main purpose of this session here. Yeah. So refactor. How did I call it the last time? Log config. Oops. Okay. Refactor. Assure we see all required field data we get. Yeah, bring in all required field data. Previously we only knew the string type, the type as string. Now we have enums and additional type information like whether or not it's a pod. Like this. Cool. However, borrow checker doesn't like the current code. Will need more work. Cool. That is that, and I thank you for watching and have a great day.